Hi, welcome back. So we're going to continue our adventures in function arithmetic. And really this is kind of the same thing as what we were doing a minute ago, but we're going to talk about a specific combination. It's called the difference quotient, and the difference quotient is always f of x plus h minus f of x all over h. This is the difference quotient, and it's a thing that comes back to haunt us in later classes, and we want to be comfortable with this, so we're going to work with it a lot in this class. So let's work some examples here. Let's suppose f of x is equal to x squared minus x minus 2. And I'm asked to find f of x plus h minus f of x all over h. All right, so I want to remind you what we do with f of x plus h. F of x plus h just says take all your x's and replace them with x plus h's. Right? And we know f of x is just x squared minus x minus 2. So we can do this. F of x plus h minus f of x all over h is equal to x plus h squared minus x plus h minus 2. That's the f of x plus h part, so I'm going to put that in brackets for now. Minus x squared minus x minus 2, that is f of x all over h. So this first set of brackets is the f of x plus h. This second set of brackets is the f of x. So all I've really done is I've taken this expression and replaced the f of x plus h with f of x plus h, and replaced the f of x with f of x. Okay? And now we need to simplify. So the first thing we need to do is expand the x plus h squared, and that is just x squared plus 2xh plus h squared. And then distribute the minus sign to the x minus h minus 2. And now distribute that second minus sign through the f of x, so that's x squared plus x plus 2 all over h. And now we combine like terms on the top, and we're going to notice that the x squareds cancel, and the 2's cancel, and the x's cancel. And what I'm left with is 2xh plus h squared minus h all over h. So now I can factor an h out on the top. Oops, sorry. And that leaves me 2x plus h minus 1 all over h. And those cancel. So I'm left with 2x plus h minus 1. Okay? Let's try that again. Let's work with the function g of x equals 3 over 2x plus 1. And I want to find f of x plus h minus f of x all over h. Okay, so, and actually what I want to find is not f of, but rather g of. So this is, g of x plus h minus g of x all over h is equal to 3 over 2 times x plus h plus 1. That's g of x plus h. Minus g of x is 3 over 2x plus 1 all over h. All right, so we've got some work to do in that numerator. And what I'm going to do is I'm going to multiply through by, what am I going to do? What am I going to do? Yeah, let's do that. Let's multiply through by 2 times x plus h plus 1 times 2x plus 1 over itself. And I'm not going to multiply anything through yet. So other than I am going to multiply this numerator all the way through on the top. So what happens is the matching denominators cancel, and I really clear the fractions on the top there. So what I end up with is 3 times 2x plus 1 minus 3 times 2 times x plus h plus 1 all over h times 2 times x plus h plus 1 times 2x plus 1. Now let's simplify in the numerator. And I've got 6x plus 3 minus 6x minus 6h minus 3 all over h times 2 times x plus h plus 1 times 2x plus 1. All right, so in the numerator we're going to combine like terms, and that gets rid of the 6x's and the 3's, and I'm left with negative 6h over h times 2 times x plus h plus 1 times 2x plus 1. The h's cancel, and my difference quotient becomes negative 6 over 2 times x plus h plus 1 times 2x plus 1, and we're just going to leave it like that. So how do you know when you're done? Well, you're done when you can't simplify anymore. Okay? All right. I'm going to do one more example with you, and then we're going to end this video. So let's do an example with a square root, because sometimes those can get a little dicey. So let's suppose the function r of x is equal to the square root of x. And again, I want to find r of x plus h minus r of x all over h. Okay, so r of x plus h minus r of x all over h is equal to the square root of x plus h minus the square root of x all over h. Now we need to do some work. We need to simplify this. You may be thinking to yourself, I can't do that. And I'm going to show you how. So what we're going to do is we're going to use the conjugate trick. So the conjugate trick harkens back to the fact that a plus b times a minus b is equal to a squared minus b squared. So when we use the conjugate trick, we're going to multiply by the conjugate of wherever the radicals are. So in this case, my square roots are all in the numerator. So I'm multiplying by the conjugate of the numerator, but I can only multiply by 1 because I cannot change a value. So when I multiply by 1, it looks like root x plus h plus x over root x plus h plus root x. It's still 1, it just looks strange. Now, why did I do that? Well, I did that because on the numerator, I'm now left with square root of x plus h squared minus the square root of x squared all over h times the square root of x plus h plus the square root of x. Now, the square root of anything squared is just the thing that's inside. It's actually the absolute value of the thing, but that's okay. So on the top I have x plus h minus x all over h times root x plus h plus root x, which gives me h over h times the square root of x plus h plus the square root of x. Cancel out those h's, and left on top is a 1. So my difference quotient for the square root of x is 1 over the square root of x plus h plus the square root of x, and that's all she wrote. All right, so that's difference quotients. I'm going to come back in the next video and we're going to talk through some economic function applications.